Tonight, without realizing it, you are drifting inside something vast, something structured, something that has been moving for billions of years without ever asking for your attention. And yet, it surrounds you completely. The Milky Way, not as a distant object, not as a picture taken by a telescope, but as the place you are already inside right now. That faint band of light you sometimes see stretching across the night sky. It feels gentle, almost decorative, easy to ignore, easy to misunderstand. But that soft glow is only the surface of something far more complex. A structure so large, so layered with hidden motion and unseen forces, that even now, scientists are still uncovering new facts about it. And here's the strange part. For most of human history, no one realized what they were looking at. Entire civilizations stared directly at the Milky Way and never understood that they were seeing their own galaxy from within. Which raises a quiet, unsettling question. If we misunderstood something this vast for so long, what else might still be hidden in plain sight? Here on Velarin's Sleepy Space Mysteries, we explore questions like this slowly, calmly, letting each mystery unfold in its own time. If you've ever listened to our video about the true scale of the universe, you already know how easily perspective can slip away when distances stretch beyond imagination. Tonight, we bring that same feeling closer into our own galactic home. Because the Milky Way is not just where we live. It is moving, evolving, quietly shaping everything around us. And the deeper you look into these Milky Way facts, the stranger it becomes. Before we begin, if you enjoy drifting through these quiet cosmic mysteries, consider subscribing, leaving a like, and turning on the bell so you don't miss future journeys. You can also join as a member if you'd like to support the channel more deeply. And as always, let me know in the comments where you're listening from tonight. Now, get comfortable, and let's begin with the first truth. We cannot see the place we live. There is something quietly disorienting about the idea that you are inside a structure so vast that you cannot step outside it to see what it truly looks like. Imagine trying to understand the shape of an entire forest while standing among the trees, your view blocked in every direction by trunks, branches, and leaves. You can walk, you can observe, you can measure, but the full pattern always escapes you. This is the exact problem humanity faced when trying to understand the Milky Way, and for thousands of years we didn't even realize it was a problem at all. When ancient civilizations looked up at the night sky, they saw that pale river of light stretching from horizon to horizon, and they did what humans naturally do when faced with mystery. They created meaning. Some believed it was a path for souls. Others imagined it as spilled milk from the gods, a celestial river, or a scar across the sky. These interpretations were poetic, comforting even, but they all shared one limitation. They assumed the Milky Way was something external, something separate from us. The truth, as it slowly emerged, was far stranger. We are not looking at the Milky Way. We are inside it. This realization did not arrive suddenly. It came through patience, curiosity, and an almost obsessive willingness to count what others ignored. In the late 1700s, a man named William Herschel began doing something that seemed almost absurd in its simplicity. Night after night, he pointed his telescope at different parts of the sky and counted stars, not just casually observing them, but systematically recording how many appeared in one direction compared to another. It was slow, repetitive work, the kind that requires a calm mind and an unusual kind of persistence. But hidden inside those numbers was a pattern waiting to be discovered. What Herschel noticed was subtle at first. When he looked along the glowing band of the Milky Way, he saw far more stars than when he looked above or below it. This suggested something important. The stars were not scattered randomly in all directions. They were arranged in a flattened structure, like a disk. Imagine grains of sand spread across a plate, dense along the surface but thin when viewed from the side. That was the first real hint that our galaxy had shape. But even this breakthrough came with a hidden limitation. Herschel was still inside the structure he was trying to map. Dust clouds blocked distant regions. Fainter stars disappeared beyond his instrument's reach. His map, though revolutionary, was incomplete, like trying to sketch a coastline while standing in the water. And so the mystery deepened rather than disappeared. If the Milky Way was a disk, how large was it? Where were we inside it? And most importantly, what did it actually look like as a whole? These questions lingered for more than a century, quietly waiting for better tools, better methods, and a deeper understanding of light itself. Because seeing the galaxy was not just about looking harder, it was about learning how to see differently. Light, as it turns out, does not always travel freely through space. Between the stars lies dust, fine particles that scatter and absorb visible light, hiding entire regions of the galaxy from view. When you look into the Milky Way, especially toward its center, you are not seeing everything that is there. You are seeing only what the light allows you to see. Vast structures remain hidden behind clouds that act like cosmic fog, concealing the deeper architecture of our galaxy. This is why, even as telescopes improved, the true shape of the Milky Way remained elusive. Astronomers were gathering more data, mapping more stars, refining their measurements, but the full picture refused to reveal itself all at once. Instead, it had to be assembled piece by piece like a puzzle scattered across time. And yet, even without seeing the entire structure, something else became clear. The Milky Way was not static. It was not a frozen arrangement of stars hanging motionless in space. Everything inside it was moving, including us. Right now, as you listen to this, you are traveling through the galaxy at a speed that feels almost impossible to comprehend. Not because you chose to move, not because you can feel it, but because you are carried along with everything around you. The Earth moves, the Sun moves, the nearby stars move, all of it drifting together in a shared motion so smooth that it feels like stillness. This is one of the quiet illusions of the Milky Way. Movement without sensation, motion without awareness. And it leads to another question. If everything is moving, what is it moving around? That answer lies deeper within the galaxy, and we are only beginning to approach it. If everything around you is moving, then the Milky Way is not just a structure you exist inside. It is a journey you are already taking part in, whether you notice it or not. The ground beneath you feels still. The air feels calm, your surroundings feel stable. And yet, all of it is being carried through the galaxy in a vast, silent orbit. The Sun, along with Earth and the rest of the solar system, is traveling around the center of the Milky Way at a speed of over 500,000 miles per hour. That number is so large it almost loses meaning, so it helps to slow it down in your mind. If you could somehow watch from far outside the galaxy, you would see our entire solar system tracing a long, curved path through space, taking hundreds of millions of years to complete a single loop. Astronomers sometimes call this a galactic year, and once you begin thinking in those terms, time itself starts to feel different. Since the age of the dinosaurs, the Sun has not even completed a full orbit. It has only moved partway along its path, drifting through one small region of the galaxy. And since the Earth first formed, the solar system has completed only about 20 of these galactic years. 20 slow revolutions through a structure that contains hundreds of billions of stars. It's a reminder that even the longest spans of human history are just brief moments within a much larger motion. But here is where the mystery deepens. The Sun is not simply orbiting in a perfect flat circle like a coin spinning on a table. Its path is more complex, more layered, almost like a gentle wave. As it moves around the galactic center, it also drifts slightly above and below the plane of the Milky Way's disk. Imagine a horse slowly rising and falling as it moves along a carousel. That subtle up and down motion is similar to what our solar system is doing right now. Over tens of millions of years, we pass through the denser middle of the galaxy, then rise above it, then fall back down again in a quiet oscillation. This vertical motion adds another dimension to our journey, and it raises a subtle question that scientists are still exploring. Does this movement affect life on Earth? Some researchers have wondered whether passing through denser regions of the galaxy might expose our planet to increased cosmic radiation or gravitational disturbances. There is ongoing debate about this idea, and no final answer yet, but it introduces an interesting possibility that our position within the Milky Way may influence conditions on Earth in ways we are only beginning to understand. At the same time, our location within the galaxy appears to be unusually calm. We are not in one of the Milky Way's major spiral arms, where star formation is more intense and massive stars live short, explosive lives. Instead, we are in a smaller structure known as the Orion Spur, a kind of quiet bridge between larger arms. This might sound like an unremarkable detail, but it could be one of the reasons life was able to develop here. In the larger arms, supernova explosions are more frequent, releasing bursts of radiation that can affect nearby star systems. Being slightly removed from those regions may have provided a kind of natural shielding, a calmer environment where life had time to evolve. And yet, even this peaceful location does not mean we are isolated. The Milky Way is filled with motion at every scale. Stars drift relative to one another, gas clouds collapse and form new stars, and the entire galaxy rotates in a way that is both structured and strangely fluid. Unlike a solid object, the galaxy does not spin as a single rigid body. Different parts move at different speeds, and this creates one of the most fascinating features of spiral galaxies: the arms themselves. At first glance, it's easy to imagine the spiral arms as fixed structures, like the blades of a fan. But in reality, they behave more like patterns than objects. A helpful way to picture this is to think about traffic on a highway. When cars slow down and bunch together, a traffic jam forms. The jam appears to stay in one place, even though the individual cars are constantly moving through it. Cars enter the jam, slow down, then speed up again as they leave, but the pattern persists. The spiral arms of the Milky Way work in a similar way. They are regions where stars, gas, and dust temporarily gather due to gravitational effects. As material moves through these regions, it becomes compressed, and this compression can trigger the formation of new stars. These young stars are often bright and blue, making the arms stand out when viewed from afar. But the stars themselves do not remain fixed in the arms forever. They drift away over time, replaced by new stars forming behind them. This means the galaxy is constantly renewing its structure, maintaining its spiral pattern without any single part remaining unchanged. It is not static. It is dynamic, evolving, quietly reshaping itself over millions and billions of years. And somewhere within this slow, flowing system lies the answer to that earlier question. What is everything orbiting? What could hold together something this vast and keep it moving in such a delicate balance? To understand that, we have to look toward the very center of the Milky Way. As we slowly move inward in our understanding, following this vast orbit toward its unseen center, something begins to feel different. Up to now, the Milky Way has seemed like a system of motion. Stars drifting, gas flowing, patterns forming and dissolving over time. But at the heart of all that motion lies a question that feels almost unavoidable. What is holding everything together? What kind of presence could guide the paths of hundreds of billions of stars without ever being directly visible to us? For a long time, astronomers did not have a clear answer. The center of the Milky Way is hidden behind thick clouds of gas and dust that block visible light, making it impossible to observe directly with ordinary telescopes. When we look toward that region in the night sky, we are not seeing the core itself, but only the outer layers of obscuring material. It is like trying to look through a dense fog at something far away. You know something is there, but the details remain hidden. And yet, even without seeing the center, scientists began to notice something unusual. The stars closest to that hidden region were moving differently. Their paths were not slow, wide orbits like the sun's. Instead, they were moving incredibly fast, tracing tight, curved paths around an invisible point in space. The closer they were to this unseen center, the faster they moved. This alone suggested something powerful was there, something with enough gravitational influence to accelerate entire stars to extraordinary speeds. But how powerful would something need to be to cause that kind of motion? To answer that, astronomers began tracking individual stars near the galactic center over many years, watching how their positions changed night after night, year after year. This required patience on a scale that mirrors the galaxy itself. No sudden discoveries, no instant answers, just careful observation, slowly building a picture from motion. One of the most important stars in this effort is known as S2. It follows a highly elongated orbit, bringing it extremely close to the center before swinging back out again. What makes S2 so remarkable is not just its path, but its speed. At its closest approach, it moves at a few percent of the speed of light, millions of miles per hour. For something as massive as a star, this is almost unimaginable. And yet, its motion is precise, predictable, and repeatable, like a cosmic clock ticking in deep space. By studying this orbit, astronomers were able to calculate the mass of whatever S2 was orbiting. The result was astonishing. At the center of the Milky Way sits an object with a mass millions of times greater than our Sun, compressed into a region smaller than our solar system. It does not shine. It does not emit visible light. And yet, its presence dominates the motion of everything around it. This object is what we now call Sagittarius A*, the gravitational anchor of our galaxy. Even hearing that name can feel distant and abstract, but its implications are very real. Every star you can see in the night sky, including our sun, is part of a system ultimately shaped by this central presence. It is not something we orbit directly in a simple sense, but it defines the structure within which all those orbits exist. And here is where the mystery becomes even more subtle. Sagittarius A* is not just massive. It is something far more extreme. It is what physicists describe as a region where gravity has become so intense that space and time themselves behave differently. Near this object, the familiar rules that govern motion begin to shift. Light can be stretched, time can slow. Paths that would seem impossible elsewhere become natural outcomes of the environment. But what is perhaps most fascinating is how invisible it remains. You cannot look up and see Sagittarius A* glowing in the sky. You cannot point to it with your eyes. Its presence is known only through its effects, through the motion of stars, the bending of light, the patterns that reveal something unseen. This echoes a theme we've been quietly building since the beginning. The idea that some of the most important parts of our galaxy are not directly visible. We infer them. We feel their influence. We reconstruct their existence through careful observation. And so the Milky Way reveals itself not all at once, but through layers. First as a band of light, then as a disk of stars, then as a system of motion, and now as something anchored by an invisible force at its core. But even this is not the full story, because Sagittarius A* is not simply sitting there unchanged. It has a history, one that hints at moments when the quiet center of our galaxy may have been anything but calm. Moments when it may have awakened. And if that is true, then the Milky Way we see today may only be a peaceful phase in a much more active and unpredictable past. By the time we arrive at this understanding, something subtle has shifted. The Milky Way is no longer just a distant idea or a faint band of light across the sky. It becomes a system you are actively part of, a structure that is moving, evolving, and quietly shaping everything around you. And yet, even with everything we've uncovered so far, there is still a strange limitation that remains. We still have never truly seen our own galaxy. Every image you've ever encountered of a spiral galaxy, those beautiful sweeping arms, glowing with soft blues and warm golds, those are always other galaxies, never our own. Because no matter how advanced our telescopes become, no matter how precise our measurements are, we remain inside the Milky Way. We cannot step outside it to take a picture. We cannot observe it from a distance. Everything we know has been reconstructed carefully, patiently, from within. This means that our understanding of the Milky Way is, in a sense, an act of imagination guided by evidence. Astronomers combine observations of star positions, motions, gas clouds, and radiation across different wavelengths of light to build a three-dimensional model. It's like assembling a sculpture while standing inside it, feeling its shape from the inside out. And over time, that sculpture has become clearer. We now understand that the Milky Way is a spiral galaxy, stretching roughly 100,000 light-years across. It contains hundreds of billions of stars, vast clouds of gas and dust, and intricate patterns that repeat across enormous distances. But even here, there is still uncertainty. Some models suggest 4 major spiral arms, while others simplify the structure into two dominant arms with smaller branches. This disagreement is not due to lack of effort. It is a direct result of our position within the system. Perspective limits clarity. But perhaps the most fascinating realization is not just the size or structure of the galaxy. It is the way it behaves. The Milky Way is not rigid. It is not perfectly flat. It is not perfectly stable. Instead, it bends, ripples, and warps over time. Observations have shown that the outer edges of the galactic disk are slightly curved, almost like the brim of a hat that has been gently bent. This warp is likely caused by gravitational interactions with smaller neighboring galaxies, subtle tugs that slowly distort the shape of the disk over millions of years. So even the structure itself is not fixed. It is responsive, sensitive to its environment, constantly adjusting. And this leads us into a deeper realization. The Milky Way is not alone. It exists within a larger system of galaxies, interacting with them, influencing them, and being influenced in return. Smaller galaxies orbit around it, some slowly drifting closer, others already being pulled apart by its gravity. Though we cannot see this process with our eyes in real time, the evidence is written across the sky in faint streams of stars, remnants of galaxies that once existed as separate systems but have since been stretched and absorbed into the Milky Way structure. This process is quiet, slow, almost gentle when viewed across human timescales. But in reality, it is a form of cosmic consumption. The galaxy grows by taking in smaller companions, blending their stars into its own, expanding its mass and complexity over billions of years, which means the Milky Way you are inside right now is not the same Milky Way that existed in the distant past. It has changed. It has grown. It has absorbed other structures, reshaped itself, and continued moving forward through time. And if that is true, then it will continue to change. The galaxy you see today is only a temporary version of something much larger and much older. Its arms will shift. The stars will drift. The center may awaken again. And far in the future, it will even collide with another galaxy, merging into something entirely new. But for now, in this moment, everything remains balanced. The spiral arms continue their slow rotation. The sun continues its quiet orbit. The Earth carries you along without a single sensation of movement. You are drifting through a galaxy that you cannot see, guided by forces you cannot feel, surrounded by structures that are constantly evolving beyond your awareness. And yet, somehow, everything aligns just enough for you to exist here, listening to this, aware of it for a brief moment in cosmic time. So as we move forward, the question is no longer just about shape or motion. It becomes something deeper. If the Milky Way is changing, if it has a past we are only beginning to uncover, and a future already set in motion, then what exactly is its story? And more importantly, what role do we play within it? If you're still here, still drifting through these quiet thoughts with me, gently let me know by commenting the number 1. And when you're ready, we'll move closer to the center, where the Milky Way becomes something far more mysterious than structure or motion alone. The closer we move toward the center of the Milky Way, the more the story begins to change. What once felt like a calm, drifting system of stars slowly reveals something far more intense. A region where motion accelerates, where distances shrink, and where the rules were used to quietly begin to bend. It is here, hidden behind vast clouds of dust, that one of the most mysterious truths about our galaxy resides. For a long time, this central region was simply unknown. Not mysterious in the sense of being dramatic or dangerous, but hidden in a very literal way. Visible light cannot pass easily through the dense gas and dust that fill the inner galaxy. So when astronomers looked toward the center, they saw very little. Just darkness, interrupted by faint glows and scattered stars. It was like staring into a closed door with no handle, knowing something was behind it, but having no way to open it. But as technology improved, scientists began to look beyond visible light. They turned to infrared and radio wavelengths, forms of light that can pass through dust more easily. And slowly, patiently, a picture began to emerge, not all at once, but through fragments, through motion, through careful tracking of objects that could be seen. And what they found was not what anyone expected. Near the center of the galaxy, stars were not drifting gently like the ones in our region. They were moving at incredible speeds, tracing tight, curved paths around a point that emitted no light at all. These were not slow, graceful orbits. They were fast, almost frantic, like leaves caught in a whirlpool. The closer the stars came to this unseen center, the faster they moved, as if something immense was pulling on them with overwhelming force. Among these stars, one in particular became the key to understanding what was happening. It is known as S2, and its orbit has been studied for decades. Unlike the Sun, which takes hundreds of millions of years to complete a single orbit around the galaxy, S2 completes its journey in just 16 years. That alone is remarkable. But what truly stands out is what happens at the closest point of its path. As S2 approaches the center, it accelerates dramatically, reaching speeds of tens of millions of miles per hour. It swings around the invisible point, then moves away again, slowing down as it climbs back outward. This motion is not random. It is precise, repeatable, predictable. And from that motion, astronomers were able to calculate something extraordinary. They were able to weigh the invisible object at the center. The result was almost impossible to comprehend. At the core of the Milky Way sits an object with the mass of about 4 million suns, compressed into a region smaller than our solar system. There is no ordinary object in the universe that can exist under those conditions. No cluster of stars, no cloud of gas, nothing we are familiar with can hold that much mass in such a small space without collapsing under its own gravity. The only explanation that fits all the observations is something far more extreme: a supermassive black hole. This object is known as Sagittarius A*, and it is not just another feature of the galaxy. It is the gravitational anchor that helps define the entire system. It does not pull every star directly like a magnet, but its presence shapes the structure of the inner galaxy, influencing the motion of stars over vast distances. And yet, despite its immense power, it remains completely invisible. You cannot see a black hole directly because light itself cannot escape from it. Once anything crosses a certain boundary, known as the event horizon, it is gone from the visible universe forever. No signal returns. No image forms. It becomes, in a sense, a permanent absence, a place where information disappears from our view. But even though we cannot see Sagittarius A* itself, we can see its effects. We see the stars racing around it. We detect bursts of energy from material falling toward it. We measure distortions in space and time near its influence. All of these clues come together to reveal something that would otherwise remain completely hidden. And here is where the story becomes even more subtle. Sagittarius A* is not currently very active. It is not consuming large amounts of matter. It is not blazing with radiation like some of the black holes found in distant galaxies. Instead, it is relatively quiet, almost dormant. It sits at the center, surrounded by swirling material, but only occasionally pulling something inward. This quiet state can be misleading, because it suggests stability, calm, even safety. But evidence suggests that this was not always the case. There are signs, faint but persistent, that the center of our galaxy was once far more active. That at some point in the past, Sagittarius A* may have awakened, consuming gas, releasing enormous amounts of energy, and lighting up the central region in ways we can barely imagine. If that is true, then the calm we observe today may only be temporary, a quiet phase between moments of activity. And that raises a question that lingers in the background. If the center has changed before, could it change again? If the center of the Milky Way was once more active, then the question becomes not just what is there, but what it has done. Because even when something as powerful as Sagittarius A* appears quiet, the galaxy itself may still carry the memory of its past behavior, like a landscape shaped by storms that have long since passed. And in recent years, astronomers have begun to notice something unusual, faint, enormous structures extending far beyond the center, as if the galaxy itself had been marked by a previous outburst. These structures are not visible to the naked eye. You cannot look up and see them stretching across the sky. They exist in high-energy wavelengths, detected only through specialized instruments designed to observe gamma rays, the most energetic form of light. When scientists mapped this radiation, they discovered two lobes extending above and below the galactic center, each reaching tens of thousands of light years into space. They are now known as the Fermi bubbles. The name might sound simple, but their existence is anything but. These massive structures suggest that, at some point in the past, something at the center of the Milky Way released an enormous amount of energy, enough to push vast quantities of matter outward, creating these towering, symmetrical shapes. And while there are still debates about their exact origin, one of the leading explanations points directly back to Sagittarius A star. It may have briefly awakened, not in a dramatic, explosive way that we would notice instantly, but in a slow, sustained feeding event. Perhaps a large cloud of gas drifted too close. Perhaps a star wandered into its gravitational reach and was torn apart. As matter spiraled inward, it would have heated up, releasing intense radiation and driving powerful outflows away from the center. Over time, those outflows could have inflated the bubbles we now observe. And here is the quiet, almost unsettling detail. This may have happened only a few million years ago. In cosmic terms, that is incredibly recent. It means that while life on Earth was already evolving, while early ancestors of modern species were walking the planet, the center of our galaxy may have been far more active than it is today. The night sky, if viewed from a different perspective, might have looked subtly different, brighter, more energized, carrying the faint signature of a central engine that had momentarily come to life. But even beyond these large-scale structures, there are smaller clues closer to the center itself. Astronomers have observed flickers of activity from Sagittarius A asterisk, brief flares of energy that appear and fade, suggesting that it is not completely dormant. These are not large events, nothing like the powerful jets seen in other galaxies, but they are reminders that the black hole is still interacting with its surroundings, still capable of change. And then there is something even more fascinating: the behavior of space and time itself near this region. When S2, the star we mentioned earlier, makes its closest approach to Sagittarius A asterisk, it enters a region where gravity becomes so strong that it begins to affect time. Not in a way that you would notice directly if you were there, but in a measurable physical sense. The light emitted by the star changes slightly, stretched by the gravitational field, and its motion deviates from what classical physics alone would predict. This effect is known as gravitational time dilation. It means that time itself passes more slowly in stronger gravitational fields. So when S2 is closest to the black hole, time for that star is, in a very real sense, moving slightly differently compared to time farther away. This is not theoretical. It has been measured, observed, and confirmed with remarkable precision. It is one of the clearest demonstrations that the rules of the universe are not fixed everywhere. They depend on where you are. And yet, even with all of this knowledge, something remains just out of reach. We still cannot see Sagittarius A asterisk directly. For years, it existed only as an inference, a conclusion drawn from motion and mathematics. But then, in 2022, something changed. A global network of radio telescopes, working together as a single Earth-sized instrument, captured the first image of the region immediately surrounding it. Not the black hole itself, but the glowing ring of material orbiting just outside its event horizon. The image is subtle, a soft, blurred circle of light surrounding a dark center. But within that simplicity lies something profound. It is the closest we have come to directly observing the edge of one of these objects, the boundary beyond which nothing returns. And what is perhaps most striking is how familiar it looks. When compared to the image of another black hole, one located in a distant galaxy, the structures appear remarkably similar. Despite differences in size, distance, and environment, the underlying pattern remains the same, which suggests something deeper, that black holes, no matter where they are found, follow the same fundamental rules. That the one at the center of our galaxy is not unique, but part of a larger pattern woven throughout the universe. And if that is true, then the Milky Way is not just shaped by something mysterious at its center. It is shaped by something that exists everywhere, something that may have played a role in the formation of galaxies themselves. And that brings us to the next question. Is the black hole simply part of the galaxy, or did it help create it? As we begin to understand the presence of Sagittarius A asterisk, another, quieter question starts to form beneath everything we've explored so far. Not just what it is or what it has done, but whether it has always been there in the way we imagine. Because when something sits at the very center of a system this vast, influencing motion across tens of thousands of light years, it becomes difficult to separate cause from effect. Did the galaxy form first, slowly gathering stars, gas, and structure, eventually creating a dense region at its center where a black hole could grow? Or did something else happen, something more subtle, where the black hole itself played a role in shaping the galaxy from the very beginning? This is not just a philosophical question. It is one of the most active areas of research in modern astronomy. And the answer, at least for now, appears to exist somewhere between these two ideas. When scientists observe other galaxies, they notice a pattern that is difficult to ignore. The size of a galaxy's central bulge, the dense cluster of older stars near its core, seems to be closely linked to the mass of its central black hole. Larger bulges tend to host more massive black holes. Smaller galaxies tend to have smaller ones. This relationship is consistent across many different types of galaxies, suggesting that the growth of a galaxy and the growth of its black hole are somehow connected. But how does that connection work? One possibility is that black holes grow alongside their galaxies, feeding on gas that falls toward the center while stars form in the surrounding regions. In this view, both the galaxy and the black hole are part of the same evolving system, influencing each other over time. As the galaxy gathers more material, some of it inevitably drifts inward, adding to the black hole's mass. At the same time, the black hole's activity, when it feeds, can release energy that affects the surrounding gas, heating it, pushing it away, or even preventing new stars from forming in certain regions. This creates a kind of balance. If the black hole grows too quickly and releases too much energy, it can push gas away, slowing further growth. If it remains quiet, gas can continue to fall inward, increasing its mass again. Over billions of years, this feedback loop may help regulate both the black hole and the galaxy, keeping them in a kind of long-term equilibrium. But there is another possibility, one that feels almost more mysterious. Some models suggest that in the very early universe, black holes may have formed before galaxies as we know them. In this scenario, small fluctuations in matter shortly after the universe began could have created dense regions that collapsed into black holes first. These black holes would then act as seeds, drawing in gas and dark matter, around which galaxies would eventually form. If this is true, then Sagittarius A* is not just something sitting at the center of the Milky Way. It may be part of the reason the Milky Way exists in its current form at all. And yet, even with these possibilities, there is no single answer that explains everything. The universe rarely offers simple explanations. Instead, it presents overlapping processes, each contributing part of the story. Galaxies and black holes may grow together, influence each other, and evolve in ways that depend on their environment, their history, and the countless interactions that shape them over time. But regardless of which explanation is closest to the truth, one thing becomes clear. The center of the Milky Way is not just a passive point. It is part of an ongoing relationship, a dynamic exchange between gravity, matter, and energy that continues even now. And yet, despite all of this influence, Sagittarius A* remains strangely quiet. Compared to the black holes found in some other galaxies, those that blaze with energy, launching jets of radiation that stretch for millions of light years, ours is almost calm, consumes very little matter. It emits relatively little energy. It sits, waiting, surrounded by stars that orbit in silence. But that calmness should not be mistaken for permanence, because the environment near the center is anything but stable. Stars pass relatively close to one another, Gas clouds drift through the region. Gravitational interactions constantly reshape the paths of objects moving through this dense space. And occasionally, something may wander too close, crossing a threshold from which there is no return. There have already been moments when astronomers thought they might witness such an event. A cloud of gas known as G2 once passed extremely close to Sagittarius A*, and for a time, scientists expected it to be torn apart, potentially triggering a visible increase in activity. But surprisingly, it survived the encounter, suggesting it may have been more than just a simple cloud. Perhaps a star hidden within dust, holding itself together against the intense gravitational forces. Moments like this hint at how delicate the balance near the center truly is. One slightly different path, one slightly closer approach, and the outcome could change completely. And so the question lingers again. If the center has the potential to awaken, if it has done so before, then what would it look like if it happened again? Not from the perspective of distant astronomers, but from here, within the Milky Way itself. Because even though we are far from the center, about 26,000 light-years away, we are still part of the same system, connected by gravity, by motion, by the structure that defines our place in the galaxy. And whatever happens at the core, in some quiet, almost imperceptible way, it becomes part of our story too. If Sagittarius A* were to awaken again, the change would not arrive as a sudden explosion in our sky, not as a dramatic flash that transforms night into day. The distance between us and the galactic center is vast, about 26,000 light-years, and that distance softens everything. It stretches light, dilutes energy, turns violent events into faint signals by the time they reach us. And yet, even softened, the effects would still be real. The center of the Milky Way would begin to glow more intensely, not in visible light at first, but across other wavelengths. X-rays, radio waves, subtle signals that would gradually reveal that something had changed. Astronomers, watching carefully as they always do, would notice the increase in activity. Instruments would detect more radiation, more motion in the surrounding gas, more signs that matter was falling inward and releasing energy as it spiraled toward the event horizon. And slowly, the quiet center would become active again. But even then, from Earth, it would not feel like a threat. We are far enough away that the most dangerous effects would dissipate long before reaching us. The galaxy is simply too large for a single event, even one as powerful as a feeding black hole, to directly disrupt life here. Instead, what would change is something more subtle, more atmospheric, almost poetic. The night sky itself might feel different. The faint region of the Milky Way that stretches across the darkness could become slightly brighter, more defined. The central bulge, the dense cluster of stars near the core, might appear more luminous, hinting at the energy being released deep within. For most people, it would still be just a faint glow easy to overlook. But for those who understand what they are seeing, it would carry a deeper meaning. A reminder that the galaxy is not static, that it breathes, in a sense, periods of calm, followed by moments of activity, unfolding over timescales so vast that they feel almost timeless. And yet, while this possibility is fascinating, there is another layer to the story that is even more immediate. Because the region surrounding Sagittarius A* is already one of the most extreme environments in the galaxy, even in its quiet state. Stars there are packed much closer together than in our region of space. Instead of light years separating neighboring stars, distances can shrink to just light days. This means that gravitational interactions are far more common. Stars can pass relatively close to each other, altering their paths, exchanging energy, sometimes even being flung outward at incredible speeds. These are known as hypervelocity stars, objects that have been accelerated so dramatically that they can escape the gravitational pull of the Milky Way entirely. Imagine a star, once part of the galaxy, suddenly launched into intergalactic space, traveling alone through the darkness between galaxies. It is a quiet but powerful reminder that even something as massive as a star can be set free under the right conditions. And all of this activity, all of this motion, is happening constantly, even now, deep within a region we cannot see directly. Which brings us back to something we've been circling around since the beginning. The idea that the most important parts of the Milky Way are often invisible. We do not see Sagittarius A asterisk itself. We do not feel the motion of our orbit. We do not notice the slow oscillation of our solar system through the galactic plane. And yet, all of these processes are shaping our reality in ways that are both subtle and profound. The galaxy is not just a backdrop. It is not just a distant structure that happens to contain us. It is an active system, a network of forces and motions that we are embedded within, carried along by without resistance. And the closer we look, the more that system begins to feel alive. Not alive in the way living organisms are, but alive in the sense that it is constantly changing, constantly responding, constantly evolving over time. The center plays its role. The spiral arms play theirs. The stars, the gas, the unseen forces that bind everything together. All of it contributes to a larger pattern that is still unfolding. And perhaps that is the most important realization of all. The Milky Way is not finished. It is not a completed structure, frozen in its current form. It is a process, one that began billions of years ago and will continue long after everything we know has changed. So as we step back from the center, carrying this understanding with us, the perspective shifts once again. Because the Milky Way is not only shaped from within, it is also shaped from the outside, by interactions, by collisions, by forces that extend far beyond its visible edges. And as we move outward in our journey, we begin to see that our galaxy is not just a home, it is part of something even larger. If you're still here, still listening, still drifting through these quiet cosmic thoughts, gently let me know by commenting the number 2. And when you're ready, we'll turn outward to the edges of the Milky Way, where it begins to reveal its most unexpected behavior. As we move outward from the center of the Milky Way, away from Sagittarius A asterisk and its quiet, immense gravity, the story does not become simpler. In some ways, it becomes even more surprising. Because while the inner galaxy reveals intense forces and hidden motion, the outer regions reveal something else entirely, something that changes how we think about what a galaxy actually is. The Milky Way is not a peaceful island of stars drifting alone through space. It is active, it is interacting, and in a slow, almost silent way, it is consuming its surroundings. This might sound dramatic at first, but the reality is far more gradual, unfolding over millions and billions of years. There are no sudden impacts, No visible collisions like those we imagine in everyday life. Instead, there are gravitational interactions, subtle at first, but relentless over time. When a smaller galaxy drifts too close to the Milky Way, it begins to feel this pull. Its stars, once bound together in their own structure, start to stretch, their paths slowly distorted. First, nothing seems to change. The galaxy remains intact. Its stars continue orbiting as they always have. But with each pass, each gradual approach, the gravitational influence grows stronger. Stars begin to drift away from their original paths, forming long, faint streams that stretch across space. These are known as stellar streams, and they are among the clearest signs that the Milky Way is actively reshaping its surroundings. If you could see these streams clearly, they would look like rivers of stars flowing through the galaxy, tracing the paths of ancient encounters. Each one tells a story, the story of a smaller galaxy that once existed independently, now stretched and absorbed into something larger. One of the most well-known examples of this process involves a small galaxy currently being torn apart as it orbits the Milky Way. Over time, it has passed through the galactic disk multiple times, and with each pass, more of its stars have been stripped away. Today, those stars form a vast looping stream that wraps around the galaxy, like a thread woven into a much larger fabric. This is not something that happened long ago and ended. It is still happening. Right now, as you listen to this, the Milky Way is continuing to grow by pulling in smaller structures, blending their stars into its own. The galaxy you are inside is not a single, original object. It is a composite built over billions of years from many smaller pieces. Some of the stars you might see in the night sky may not have formed in the Milky Way at all. They may have originated in other galaxies, long since absorbed, their histories now hidden within the larger structure. This idea shifts perspective in a quiet but profound way. The Milky Way is not just a home, it is an archive, a record of past encounters, written in the motion of stars and the faint patterns that stretch across space. Every stream, every cluster, every subtle irregularity in the galaxy's structure carries information about something that happened long before humans ever existed. And this process of galactic growth is not unique. It happens throughout the universe. Large galaxies grow by merging with smaller ones, gradually increasing their mass, reshaping their structure, and evolving over time. It is one of the fundamental ways that cosmic structures develop. But even as the Milky Way continues this slow process of absorption, something much larger is already approaching. Far beyond the outer edges of our galaxy, another massive system is moving through space, gradually drawing closer over billions of years. It is similar in size to the Milky Way, similar in structure, another vast spiral of stars. And its path is set. In about 4 to 5 billion years, the Milky Way will collide with it. This galaxy is known as Andromeda. At first, the idea of a galactic collision might sound catastrophic, like something that would destroy everything in its path. But the reality is more subtle. Galaxies are mostly empty space. The distances between stars are so vast that even when two galaxies pass through each other, direct collisions between individual stars are extremely unlikely. Instead, what happens is something more graceful and more complex. As the two galaxies approach, their gravitational fields begin to interact. Spiral arms stretch and distort. Long streams of stars are pulled outward, gas clouds collide and compress, triggering bursts of new star formation. The structure of both galaxies begins to change, not through impact, but through influence. They will pass through each other separate, then fall back together again, repeating this process over hundreds of millions of years. Each pass will reshape them further, gradually dissolving their original spiral patterns. And eventually they will merge into a single, larger galaxy, something different from either of them before. By the time this happens, our sun will be nearing the end of its life. The Earth itself may no longer be habitable. Humanity, if it still exists in any recognizable form, will have long since adapted, moved, or transformed beyond what we can currently imagine. But the galaxy, the structure that carried us through time, will continue evolving. And this leads to a quiet realization. The Milky Way is not permanent. It is part of a much larger story, one that extends far beyond its current form. And yet, even this is only part of the picture, because everything we have described so far, the stars, the gas, the motion, the collisions, accounts for only a small fraction of what actually exists within the galaxy. There is something else, something invisible, something far more massive than everything we can see. And it is quietly holding the entire system together. Up to this point, everything we've explored about the Milky Way has involved things we can, in some way, detect directly: stars that shine, gas clouds that glow, motion that can be measured. But now we arrive at something far more elusive, something that does not emit light, does not reflect it, and does not interact with it in any way we can easily observe. And yet, without it, the galaxy you are inside would not exist in its current form. This is where the story becomes quietly unsettling. Because if you could somehow gather all the visible matter in the Milky Way, all the stars, all the planets, all the gas and dust, and weigh it, you would find that it accounts for only a small fraction of the galaxy's total mass. Less than 15%. The remaining 85% is something else entirely, something invisible. Astronomers call it dark matter. And despite decades of study, we still do not know exactly what it is. The first clues appeared not within our own galaxy, but in the motion of galaxies themselves. When scientists measured how fast stars were moving in spiral galaxies, they expected to see something similar to what we observe in our solar system. Planets closer to the sun move faster, while those farther away move more slowly. It's a natural consequence of gravity. But galaxies did not behave this way. Stars far from the center were moving just as fast as those closer in. In some cases, they were moving even faster. According to everything we understood about gravity, those outer stars should not have been able to stay in orbit. They should have drifted away into intergalactic space. And yet, they didn't. Something unseen was holding them in place. To account for this, astronomers proposed the existence of a vast halo of invisible matter surrounding each galaxy, extending far beyond the visible disk. This halo would provide the additional gravitational pull needed to keep those fast-moving outer stars bound to the system. And over time, more and more observations began to support this idea. The Milky Way, it turns out, is embedded within such a halo. This halo is enormous, far larger than the visible galaxy itself. While the spiral disk stretches about 100,000 light-years across, the dark matter halo may extend several times farther, enveloping the entire system in an invisible structure. And here is the part that shifts perspective completely. The stars you see in the night sky, the glowing band of the Milky Way, all of it is just a small, visible layer within a much larger, unseen framework. Like foam on the surface of a deep ocean. This means that when you look up at the night sky, you are not seeing most of the galaxy. You are seeing only the parts that interact with light. The majority of its mass, the majority of its gravitational influence remains hidden. And yet, it is this hidden component that holds everything together. Without dark matter, the galaxy would not be stable. The stars would not orbit in the way they do. The structure itself might not have formed at all. Computer simulations have shown that without this invisible mass, galaxies would struggle to maintain their shape. They would disperse, unable to hold themselves together against their own motion. So even though we cannot see it, dark matter is not optional. It is essential. But what is it made of? This is where the mystery deepens again. Scientists have proposed many possibilities, most of them involving particles that do not interact with light, only with gravity. These particles would pass through ordinary matter almost completely unnoticed, like shadows moving through walls. Right now, as you sit here listening, countless dark matter particles may be passing through your body, through the earth, through everything around you, without leaving any trace. Experiments around the world are searching for these particles. Some detectors are placed deep underground, shielded from other sources of radiation, waiting for the faintest possible interaction. Others look for subtle signals in space, hoping to catch indirect evidence of dark matter's presence. So far, no definitive detection has been confirmed, which means that most of the galaxy remains unknown. And this realization carries a quiet weight, because it suggests that everything we perceive, everything we can see and measure directly, is only a small part of reality. The rest exists beyond our senses, influencing the universe in ways we can only infer. It is as if the Milky Way has an invisible skeleton, a hidden structure that supports everything we observe, but cannot itself be seen. And once you begin to think about it that way, the galaxy feels different again. Less like a collection of stars, and more like a layered system where the visible and invisible are constantly interacting, where motion is guided by forces we cannot touch, where the majority of what exists is hidden yet essential. And perhaps the most intriguing part of all is that this invisible structure does not just belong to the Milky Way. It extends far beyond it, connecting galaxies across the universe, forming vast networks that stretch across unimaginable distances. Which means the story is not just about our galaxy anymore. It is about something much larger, something that connects everything. As we follow this idea outward, beyond the visible stars, beyond the dark matter halo that surrounds the Milky Way, the scale of the story expands once again. Because the invisible structure we've been describing does not stop at the edge of our galaxy. It continues, stretching outward into the universe, connecting galaxies together in ways that are both subtle and immense. Imagine, for a moment, that you could step far enough away from the Milky Way to see it not as a band of light, but as a single object, a spiral of stars embedded within a vast, unseen halo. And then imagine stepping even farther back, far enough to see other galaxies nearby. You would begin to notice something remarkable. These galaxies are not scattered randomly. They are arranged along faint, thread-like structures, forming a kind of cosmic web. This web is shaped largely by dark matter. It acts as a framework, a scaffolding upon which visible matter gathers. Over billions of years, gravity pulls gas toward the densest regions of this invisible network. That gas cools, condenses, and forms stars. Galaxies emerge at the intersections of these filaments, where the concentration of matter is highest. In this way, the Milky Way is not just floating in empty space. It is anchored within a much larger structure, connected to other galaxies through this vast, unseen web. And within that web, motion continues. Galaxies drift toward one another, pulled along these invisible pathways. Some pass by at great distances. Others come close enough to interact, to merge, to reshape each other over time. The collision with Andromeda that we mentioned earlier is just one example of this larger pattern. It is not an isolated event. It is part of a continuous process unfolding across the universe. But even as galaxies move through this cosmic web, something else is happening on a smaller, more intimate scale. Something that connects directly back to the space between the stars within the Milky Way itself. Because between those stars, in the vast regions that might seem empty at first glance, there exists a complex, dynamic environment known as the interstellar medium. It is made of gas, dust, and magnetic fields spread thinly across space, yet playing a crucial role in the life of the galaxy. This medium is not uniform. In some regions, it is cold and dense, forming massive molecular clouds where new stars are born. These clouds can span hundreds of light years, containing enough material to create thousands of stars over time. Gravity slowly pulls the gas inward, compressing it until nuclear fusion begins, igniting new points of light within the darkness. In other regions, the interstellar medium is warm, shaped by the radiation of nearby stars. And in still others, it becomes incredibly hot, heated by the explosive deaths of massive stars, supernovae that send shockwaves rippling through space. These shockwaves stir the surrounding gas, mix its elements, and distribute the materials needed for future generations of stars and planets. This creates a cycle. Gas forms stars. Stars live and evolve. And when they die, they return their material to the interstellar medium, enriching it with heavier elements. Those elements eventually become part of new stars, new planets, and potentially new forms of life. The atoms in your body, the oxygen you breathe, the carbon that forms your cells were once part of this cycle. They were forged in stars that existed long before our sun was born, scattered into space, and eventually incorporated into the cloud that formed our solar system. In this sense, the interstellar medium is not just a background feature of the galaxy. It is the source of continuity, the thread that connects past stars to future ones. And woven through this medium are magnetic fields, vast, invisible lines of force that stretch across light years. These fields influence how gas moves, how clouds collapse, and how energy flows through the galaxy. They guide charged particles, shape the formation of structures, and contribute to the overall dynamics of the Milky Way in ways that are still being studied. So once again, we return to a familiar theme. The most important parts of the galaxy are often the ones we cannot see directly. The dark matter halo, the cosmic web, the interstellar medium, the magnetic fields. All of these invisible or nearly invisible components are essential to the galaxy's existence. Without them, the stars alone would not form the structure we observe. And when you begin to layer all of these elements together, the Milky Way starts to feel less like a simple collection of stars, and more like a living system, not alive in the biological sense, but alive in its behavior, constantly cycling matter, redistributing energy, evolving over time. A system where everything is connected, from the smallest particles passing through space to the largest structures stretching across the universe. And somewhere within that system is you, not separate from it, but part of it, a brief moment of awareness within a structure that has been evolving for billions of years and will continue long after this moment has passed. And so, as everything begins to settle, as the motion slows in our imagination, we arrive at a quieter understanding of the Milky Way, not as something distant or overwhelming, but as something continuous, something you are already inside, already moving with, already part of in ways that are easy to forget. Because after everything we've explored, the hidden center, the silent black hole, the unseen dark matter, the slow consumption of neighboring galaxies, the vast cosmic web stretching beyond it all, what remains is not just a collection of facts, but a shift in perspective. The Milky Way is not a static place. It is not a finished structure. It is a process unfolding. Right now, in this moment, stars are being born in cold, quiet clouds of gas. Somewhere else, a star is reaching the end of its life, preparing to release its material back into space. In the distant center, matter drifts slowly toward Sagittarius A asterisk, perhaps one day crossing a boundary from which it will never return. At the edges, faint streams of stars continue to stretch, remnants of galaxies that no longer exist as separate identities. All of it happening at once, all of it part of the same system, and yet, from where you are, it feels still. The ground does not move beneath you. The sky does not shift dramatically from one night to the next. The Milky Way appears as a soft, unmoving band, quiet, almost timeless. But now you know that this stillness is only an illusion. Beneath it is motion, immense, continuous, and precise. You are moving with the Earth. The Earth is moving with the Sun. The Sun is orbiting within the galaxy. And the galaxy itself is moving through the universe, guided by forces that extend far beyond what we can see. It is a layered motion, one that carries you gently, without resistance, without sensation. A kind of cosmic drifting that has been ongoing for billions of years. And within that drifting, something else emerges. A sense of connection, because the atoms that make up your body were once part of this galaxy in a different form. They existed in stars that lived and died long before the sun was born. They traveled through the interstellar medium, becoming part of the cloud that formed our solar system. And now, for a brief moment, they exist as you, aware of the galaxy they came from. It is a quiet loop. The galaxy creates stars. Stars create elements. Those elements become planets, and eventually, life. And that life looks back and begins to understand the system it came from. There is something deeply calm about that realization. Not overwhelming, not urgent, just steady. A reminder that even in a universe filled with motion and change, there is also continuity. A slow, ongoing story that connects past, present, and future in ways that do not need to be rushed or fully understood all at once. And as you sit here listening, drifting through these thoughts, the Milky Way continues exactly as it always has. The spiral arms turning slowly, the stars following their paths, the unseen matter holding everything together. Nothing pauses, nothing waits, and yet, for this moment, you can rest within it. You can imagine the vast structure surrounding you, not as something distant or abstract, but as something gentle, something steady, something that has been carrying you this entire time without ever asking for your attention. And maybe that is the final, quiet truth hidden within all these Milky Way facts, that the universe does not need to be loud to be extraordinary. It does not need to rush to be meaningful. Sometimes, it simply unfolds, slowly, silently, endlessly. If you've stayed with me all the way to the end, gently let me know by commenting the number 3. It's a small signal, but it tells me you're still here, still drifting through these quiet mysteries with me. And for now, let the motion continue and allow yourself to drift with it.